That's Stray's tutoring? Hey guys, welcome to today's video where we'll be going over the combined gas laws. In previous videos, in this very long sequence of videos that I have where I go over different gas laws, we finally reached the law where we combine all that stuff together. So I've already talked about Charles' law, the Gay-Lussac's, and Boyle's law. If you guys haven't already checked those videos out, they should be under the playlist Chemistry 1 and 2 topics if you guys just want to watch the full videos. But I will not ever leave you guys hanging like that because we actually have a recap. So in our second slide, we'll go over some of the laws that we talked about before. The first law that we have is Charles' law. And if you guys have good memory, which I hope you guys do, we talked about a hot air balloon and where there is like a flame or a torch that will help expand the balloon, therefore it can float. And when we have this increase in temperature, what we have is an increase in volume, and this is a direct relationship. So if we were to lower the temperature of that flame, then the volume would decrease, or this hot air balloon will shrink. Okay, now with Boyle's law, we have a relationship between pressure and volume, where pressure increases when volume decreases. So in this second photo that we have here, so I'll just label this 1 and 2. In this second one, we have, as you can see, a very lower volume compared to this one. So this volume is decreased. So when volume decreases, pressure increases. And to our first photo, we can see that this volume is greater. So this has a greater volume. So as volume increases, pressure decreases. And this relationship is inversely proportional, where when one goes up, one goes down, one goes down, one goes up. As to in our first law, Charles' law, there's a direct relationship where either both go up or both go down, okay? Lastly, we have our Gay-Lussac's, where this is the relationship between pressure and temperature, and volume is held constant, and the amount of gas that's in there, which is categorized by N. So N and V are constant. So as you guys see here, these two volumes are the same. They are constant. However, if we were to add temperature, so we have a flame here and this one does not. If we add temperature, the pressure increases. We have a small gauge here if you guys see. Boom and boom. So when we added this flame, we can see that the temperature went up compared to this one. It's just stuck at the measly 2. As for this one, the pressure increased to 4. And this can be in bar, ATM, and different units. If you guys want to learn more about those units, check out the previous video. But we can say that temperature helps the pressure increase. It's dependent on the temperature. So the higher the temperature, the more pressure. And that's only if the volume and the amount of gas in that container is constant. Okay, so now that we talked about all the laws, let's put this all together into the combined gas law. The combined gas law is an equation, just like the rest of the laws that we talked about. They have equations, of course. Now we're going to combine all of them together. And let's go over some definitions real quick. The combined gas law. This is all pressure, volume, and temperature relationships that are combined into a single relationship called the combined gas law. So this studies the effects of changes in two of these variables on the third. So now this seems a little confusing because we're just used to seeing two variables. It's either volume and temp, or pressure and temp, or pressure and volume. Now we're adding 3. We're adding pressure, volume, and temperature. And an important thing to keep in mind is that N, or the moles, or the amount of gas, is held constant. That's why you see this little N here tucked. But typically when you guys see the combined gas law, the equation that you guys will see is P1 V1 over T1 equals P2V2 over T2. And something I didn't mention in the other videos, I know I go over different conditions and ways to set up the problem, which in the next slide we'll have an example of that. But think that the left side will have all the P1s or the initials or the first conditions. And then on the second side, you'll have the P2, V2, T2s, all the 2s or the second condition on the right side. And you guys can see it here too, where it's almost pretty much the same across all the laws, where all the 1s are to the left and the 2s are to the right. Same deal here, same deal here, same deal here, same deal there. So let's get into our problem, word problems that everyone loves. I can't lie to you guys, this was very hard for me when I was in chemistry and a lot of my classes. I used to hate the word problems. I was terrible at word problems. But if you know how to set it up, you guys should be set. So it says a 25 ml bubble is released from a diver's air tank at a pressure of 4 atm and a temperature of 11 degrees Celsius. What is the volume in ml of the bubble when it reaches the ocean surface, where the pressure is 1 atm and the temperature is 18 degrees Celsius? Already reading that, I am going nuts and I don't even know what I read. And that happens a lot of times with these word problems. But let's go ahead and set this up. So the first thing that we want to do is convert degrees Celsius to Kelvin. So we will start with T1 and T2. So what is our T1? T1 is the first temperature that they provide us, which is 11 degrees Celsius. So that will be 11 degrees Celsius plus 273 equals 284 Kelvin. T2 will be the second temperature provided, which is 18 degrees Celsius. So that'll be 18 degrees Celsius plus 273 equals 291 Kelvin. Okay, next what we want to go ahead and do is get our conditions ready. So let's go ahead and do it. So we have P1, V1, T1. And then for our second conditions, we have P2, V2, and T2. So what is P1? P1 is given. The first pressure listed here is 4 atm. So we can go ahead and put 4 atm. What is the V1, or the first volume given to us? The first volume given to us is 25 ml. So we'll go ahead and put 25 ml. What's the first temperature given to us? It's the 11 degrees Celsius, which we converted to 284. So the T1 would be 284 Kelvin. Okay? How are you guys doing so far? You guys with me? I wish you guys could talk to me through the screen, but I will assume you guys are okay. If not, pause and just go back, ask questions down below. For P2, the second pressure that's given is what? Here. It is 1 atm. How about the second volume? Well, we aren't given the second volume because it is what is the volume of the bubble and so on and so forth. So we're looking for what this second volume will be. So we'll just put a question mark there. T2, what is the second temperature? The second temperature is given, the 18 degrees Celsius, which we converted to 291 Kelvin. All right, so now we have everything that's needed. And so what I'll go ahead and do, and I love this feature, I'm going to go ahead and copy this and I'm going to paste it here. So we have our conditions ready. Now what we need to do is isolate. What are we looking for? We are looking for the volume, right? So that's what we're looking for. This is what we need, but we have all the stuff here, all the necessary things we need to plug into our equation. But first we have to isolate that V2. So let's go ahead and write out the equation. So we have P1 V1 over T1 equals P2 V2 over T2. Now to isolate this, what we'll do is I'll rewrite the equation once more. T1 times well, what we'll do is we'll actually get rid of this side here. So let's go ahead and write P2 V2 over T2. And how we'll do this is we'll multiply both sides by T2. And so on this side, we will also do T2 P2. So in essence, and I'll highlight here, we'll multiply both sides by T2 over P2 so we can cancel out the temperature and pressure. So now what we have is we can cancel this, cancel this, cancel this, cancel this. And now what we're left with is V2 equals V1 times P1 over P2 times T2 over T1. Okay, so now what we can now do is go ahead and plug and play. So if we go ahead and plug and play, we can say that V2, again, our equation is V1 times P1 over P2 times T2 over T1. So V1 will be the 25 ml, because that's the first volume given, times P1 over P2. P1 is the first pressure given, which is 4, and the second pressure is 1. So this will be 4 atm over 1 atm times T2 over T1. And we know that the second temperature that we got is 291 and the first temperature is 284. So we can do 291 K over 284 Kelvin. And all of these will cancel out as far as the units. And if we multiply across using our trusty calculator, we get 102 ml, which is our answer. And that is it, guys. This is how you will solve a combined gas law equation. So we have the initial volume V1, P1, P2, T1, T2, and the V2, or second volume, is what we're looking for. All right, so that concludes this video. I will create a video with multiple equations, and that will probably be the hour-long video that I haven't done in a long time. I have an hour-long video with an organic chemistry video, so I'll do the same thing here. So let me know what you guys think. If you guys have any questions, leave them down below. I'll catch you guys next video. Peace.